Today we're going to talk about multiplying and dividing rational expressions. So rational expression, again, means that it's a fraction. So today we're going to talk about how to multiply and divide fractions. Like super, super big idea. Very common mistake that students make. When you are wanting to reduce a fraction, you can only divide something that is being multiplied, because division and multiplication are inverses of each other. That's what undoes each other. Dividing does not undo addition. So you cannot divide a part of an addition problem. Okay? You cannot divide part of an addition. You can divide multiplication, but you cannot divide addition. So that means if we have an addition problem, what we're going to want to do is factor it to turn it into a multiplication problem. So factoring is going to be pretty important to us today. So what I mean is, in this problem, you can't cancel the x squareds. A lot of students want to. There's one on the top and the bottom, and we want to cancel them. But canceling undoes multiplication. It doesn't undo addition, and that's what we have here is addition. So to turn this addition into multiplication, that's what factoring does. So when we factor, we're looking for what multiplies to make the last number, that adds to make the middle number. So when we learned this back in chapter 5, we made a chart of things that we can multiply and get that last number. And we want to choose the set that adds to make the middle number. So plus 2 and minus 6. And so then our factors are going to be x plus 2 and x minus 6.
It's what adds to make the last number.
Multiplies to make the last and adds to make the middle. On the bottom, this is a special factoring form for us. It doesn't have a middle term, so we could in essence say the middle term is 0, right? Because it's not there. We don't have the x term. So we want to multiply to make negative 4 and add to make 0. So what could we do with that?
Negative 2 and positive 2.
Plus and minus 2. When we have that, what we call a difference of squares, where they're both perfect squares, we do the square roots plus each other and the square roots minus each other. So we spent a long time doing this stuff back in chapter 5, but it's been a little while. So you might remember when I talked about how, like in algebra 1, the big idea is linear equations. And how do we solve something with an x in it? And then when we come into algebra 2, our big idea is quadratic equations and how we solve these quadratics, and factoring is a skill that we use for quadratics. Trig is also pretty important to us. We spend a lot of time on that. Those are kind of the two big ideas. And then these other things that we look at throughout the course are just kind of an introduction. And if you go on to pre-calc next year, then you'll kind of dig deeper into each of these individual topics that we've talked about. So now that we've turned this into a multiplication problem, because it's in parentheses, it's multiplying now, I can cancel out a whole part that's being multiplied if it matches on top and bottom. So I have an x plus 2 that matches on top and bottom, and I can cancel out that whole part. I can't cancel out just a piece of an addition or a subtraction, but I can cancel out a whole group that matches. So then what's left is x minus 2, or rather x minus 6 over x minus 2. And that's done. You can't cancel the x's because that's part of an addition. You can't reduce the 6 and 2 because that's part of an addition.
Can you go over how you got the bottom?
Yep. So this is a special factoring form where they're both perfect squares. And our rule is that we're going to do the square root plus and the square root minus. Another way to think about it is this is like x squared plus 0x minus 4. So I'm going to multiply to make negative 4 and add to make 0. So it'd be positive and negative 2. So on this one, we want to factor at the top. In factoring the top, we're looking for what multiplies to make negative 6. That adds to make negative 5. I think 6 is the trickiest one because we could actually make a 5 out of either one of those sets. So we have to be careful that our signs are all lining up right. We want it to be a negative 5, and we want to multiply to make a negative 6. So if I'm multiplying to make a negative, what does that mean about my signs?
You have to have a negative.
I have to have one of each. So if I have to have one of each and I want to make a negative 5, then I need to do it with a plus 1 and minus 6. Because I could do it with the 2 and 3, but I would need them to both be negative, and then that would multiply to make a positive 6, and that's not what we want. I think 6s are the trickiest. The bottom is that difference of squares again. So then we do the square root plus and the square root minus. We get a matching group. And then we're left with x minus 6 over x minus 1.
How did you find what was on the bottom?
That's our special factoring form of they're both perfect squares, because x squared I can take a square root of, or 1 I can take a square root of. So we do the square roots added and the square roots subtracted. Alright, and this is done. We can't cancel the x's. We can't, do double negatives, or we can't do anything else to that, because now it's just an addition and subtraction on top and bottom, and we cannot cancel addition and subtraction with division. When we want to multiply fractions, when we multiply fractions, we do not cross multiply. So that is a really common misconception that when students learn to cross multiply, they want to cross multiply every time they see two fractions. Okay, cross multiplying is only done when there's an equal sign between fractions. Cross multiplying solves an equation. Okay? When we multiply fractions, we just multiply the tops and we multiply the bottoms. And we're going to want to then simplify the way that we just did these other ones. If it's a polynomial, we're going to factor before we multiply. So this one is not a polynomial because there's no adding and subtracting. It's just all stuff being multiplied. There's no pluses or minuses in here. It's just all multiplying. So I'm going to multiply the tops of the fractions. Multiply the number. Gives 30. How many x's? X to the fifth. We add up those exponents. And y to the third. Over on the bottom, multiply and I get 20. There's just one x, add up the y's, and I get 4. Then since this is all multiplying, there's no pluses and minuses, we can reduce any part of it that matches. So I can reduce the 30 and 20 to just get 3 over 2. If I have 1x on bottom and 5 on top, I can cancel out one of those to have just 4 left on top. And if I have 3 y's on top and 4 on bottom, I can cancel them out and I'll have just 1 y left over on bottom.
So you can multiply like the 2xy times 10y when x and y are together.
Yep. Since there's no adding or subtracting, we can just multiply the pieces that go together. So on the top, I'm left with 3 x to the 4th. On the bottom, 2 and y to the 1st, or just y.
So you're not like doing like 5 times 6 and then x 3 and then y, like it's not, you're not distributing, you're just doing.
We're not distributing because
5.
there's no pluses. So
So
distributing something
same
you do when
things
you're adding.
times same things.
Yep. Yep. Distributing something we do when we add. Here, there's no adding, so we're just multiplying together the numbers and then combining together our x's and y's.
You just simplify the 30 and 20.
Yep. Yep, I reduced them down by 10.
You just reduce like that.
Yep. Yep, since there's no adding or subtracting in there, it's all multiplying, we can just reduce it down.
So wouldn't it be, oh, never mind.
Okay, so in this one, we multiply together the tops, multiply the number, 60. Put the x's together, 2 and 3 more makes 5. Put the y's together, 3 and 4 more makes 7. On the bottom, multiply the numbers, 36. X squared. Put the y's together, there's 4 of them. And then we can reduce. 60 and 36 both divide by 12 to leave 5 over 3. If you didn't notice that 12 goes into them and you pick something smaller like 6, that's fine, and then you'll just reduce some more. For the x's, I can cancel out 2 of those and it'll leave 3 left over on top. And for the y's, I can cancel them and leave 3 left over on top. So I'm left with a 5 and a 3, an x cubed and a y cubed both on top. Questions? When we have adding or subtracting, so when we have polynomials, we don't want to multiply these together, because if we did, we would need to like claw them all out or like FOIL them all out, which would be a very long process. And then to be able to cancel anything, we would have to factor them down, and that type of factoring is not even something that we've learned. So instead of multiplying them together first, we're going to factor them first. Okay, so when there's adding or subtracting, we want to start with factoring. So on the top of that first fraction, what do those two terms have in common? 4x. So I can take a 4x outside, and that would leave a 1 minus x inside. When you are factoring, you're dividing something outside of the group. So 4x divided by 4x leaves a 1. And 4x squared divided by 4x leaves an x. You can always double check and say, if I would redistribute that back in, do I end up with what I started with? And you should. If you don't, you factored it wrong. Okay? So always think about redistributing and see if you get what you started with. On the bottom of that, we're looking for multiply to make -3 and add to make +2. So that'd be a +3 and a -1. Multiplies to make -3 and adds to make +2. Top of the second one, I want to multiply to make -6 and add to make +1. Use a +3 and -2. Multiplies to make -6, adds to make +1. And in the bottom, there isn't any adding or subtracting. It's just a 4x. That's all there is. That can't be factored. You can only factor if you have pluses and minuses and stuff.
Why didn't we factor the x squared plus x minus 6?
I did. That's the x plus 3x minus 2.
Right.
Okay. So factor out each of the 4 parts if they can be factored. That 4x on the bottom can't be factored because it's just one thing. Then we want to look for what matches to cancel. So the 4x matches the 4x. The x plus 3 matches the x plus 3. And then we have kind of a weird thing. Those don't perfectly match each other, right? And subtraction matters. Like 2 minus 3 is different than 3 minus 2, right? Just a little side note here. If I do 2 minus 3 over 3 minus 2, I get -1 over 1, or -1, right? What about if I do like 10 minus 4 over 4 minus 10? 6 over -6 is -1. There's not anything special about the numbers that I'm picking. When you are subtracting backwards, right, it will always result in a -1. So we can cancel those, but they don't disappear. They get replaced with a -1. And when you're dividing two things that subtract backwards, you can cancel them, but they don't totally disappear. They get replaced with a -1. So then I gotta find what's left over, what haven't I crossed out. So I've got that -1, and I've got an x minus 2. So I've got a -1 times x minus 2, which I would be okay with you leaving, or you could distribute that and say I've got a -x plus 2, either way. Okay, so when you're multiplying polynomials, things that have adding and subtracting, factor each part first and then look for what matches to cancel. You cannot cancel parts of additions and subtractions. So you can't cancel anything off at the beginning of this problem because everything has a plus or a minus to it. So we can't cancel any of that stuff off until we turn it into parentheses. On the top of that first one, what is in common? 3x. If I take that out, I get 1 minus 9x squared. That factors more. What do you notice about 1 and 9? What kind of numbers are they? What kind of special numbers? They're perfect squares. So this is our difference of squares, where we can do the square root of the first thing, the square root of the second thing with a plus and a minus. On the bottom, when we factor here, we have a 3 in front of our x squared. So that means we need a 3x and an x to make the 3x squared. Then I want to multiply at the end to make a 1. So that would be a 1 and a 1. And then to figure out our signs, we want to think about foiling this thing back out. So if I did a 3x and an x, I want them to add up to the middle, the negative 2x. So I need a negative 3 and a positive 1. So a negative there, positive there. Okay. When we have that number in front of our x squared, we have to think about kind of the whole refoiling process to figure out how our signs and numbers go.
Is that just that first?
So that's the first fraction. Okay, so when we have the 3 in front of the x squared, I'm going to need a 3x and an x. 1, thankfully, we don't have any options. It's just 1 and 1. And then think about what your outsides would do and what your insides would do to add up to make the middle. We have that same thing happen on the top of the next one, so we can practice that again. So I need a 3x and an x to make the 3x squared. I need a 1 and a 1. And then I want to think about what my outsides and insides would do. A 3x and an x. And I want to make a minus 4. So I need them to both be negative. The bottom's nice, we can't factor it, it's just a 3x. So then we want to find stuff that matches. So the 3x matches the 3x. The x minus 1 matches the x minus 1. Then on the top, I have a 1 plus 3x. On the bottom, I have a 3x plus 1. Are those exactly the same, or are they going to do the negative 1 cancel? They're exactly the same because they're adding. And 2 plus 3 is 3 plus 2. When we add, it doesn't matter what order we're adding in. So 1x plus 3 is exactly the same as 3x plus 1. So then the stuff that I have left is on the top, a 1 minus 3x. And a 3x minus 1. I can't cancel them because they're both on the top. And so then That's gonna be our answer, and you do not need to redistribute it back out, just leave it in its factored form. Questions? When we divide fractions, we multiply by a reciprocal. So we're gonna flip over the second fraction and then change it into a multiplication problem. So it'll become exactly like this last type of problem. So I'll have more practice with that here. We should have one additional step at the beginning when you're dividing. You just flip it over first. So we always wanna flip over the second one. So I'm gonna leave the first one just what it is. 5x over 3x minus 12 times, flip over the second fraction. And then this problem becomes exactly like the last type of problem. We want to factor each numerator and denominator when possible. The 5x is only one thing, so there's nothing to do with that. 3x minus 12, what do they have in common? 3, which would leave an x minus 4. Top of the second one, I want to multiply to 8 and add to negative 6. It's going to be a minus 4 and minus 2. Bottom of the second one, what do they have in common? An x, which will leave an x minus 2. So then we want to look for what matches. X minus 2 matches x minus 2. X minus 4 matches x minus 4. The x matches the x. You don't have to cancel the numbers with the x's, just like we did on the very first type of problem when there wasn't any adding and subtracting. We just multiplied together all the numbers, multiplied together all the x's. We could just cancel x's with x's and not worry about what number they were, and that's fine to do. So we can cancel those x's. And then we just look for whatever's left over, and all that is left over is a 5 over 3. I know I'm a math teacher, so I'm kind of weird, but I like these problems because they're like really super messy, and then they typically end up nice and clean and neat and organized, and I really like that. This one says multiply and divide, so we want to multiply where it says multiply and divide where it says divide. So anything that comes directly after a divide sign is going to be flipped over. So that first fraction I'm not going to do anything with. That second part isn't a fraction, but I'm going to make it one. I'm going to make it 2x plus 3 over 1. And then that last one's a divide, so I'm going to flip it over. Anything that comes directly after a divide, flip over. And then we want to factor what can be factored. There's actually not a lot to factor on this one. We've got an x. That's only one thing that can be factored. X minus 2 doesn't have anything in common, so we can't factor it. I am going to put it in a group, though, and say, like, I tried to factor it. There was just nothing that could come out, so it's all grouped up now. The 2x plus 3 is grouped up, and there's nothing in common there. Just a plain 1. X minus 2, nothing to do with that, so I'll just group it up. 4x squared minus 9, there is something to do with, though. What do you notice about 4 and 9? They are perfect squares. So 2x plus 3 and 2x minus 3. We have that subtraction of perfect squares. We do the square roots plus and the square roots minus. Then we find what matches. I see a 2x plus 3. I see an x minus 2. And what's left over is an x and a 2x minus 3. And I can't cancel those x's because that would be canceling then part of an addition problem, and I can't do that. Questions? (9.4) for your assignment.